Alrighty, everybody, welcome back. We're going to go ahead and take a look at the Lesson 4-3 assignment together. I know this homework assignment is very, very difficult because it is a lot, right? And it requires you to have a deep understanding of parallel lines and cut by a transversal. So let's go ahead and take a look at some problems together. Let me go ahead and pull up the key. Okay, so number 25. I'm not going to go over everything in regards to number 25, but it's so important that you read what it's asking. So, for instance, it says given angle 1 is congruent to angle 3, and we know from the given that segment AC is parallel to segment BD. So I'm going to go ahead and mark angle 1 and angle 3 on my picture to show that they are congruent. And now what I'm going to go ahead and do, because I know that these things are segments, right? And actually, this one's like a ray and such. Like this is a ray, this is a ray, this is a segment, and this is a segment. I'm going to mark my picture to show that segment AC, which is right here, is parallel to this segment BD. Okay. So just drawing those two arrows. And then I'm going to extend the lines, okay? I'm just going to extend those lines or those segments or those rays or whatever. I'm just going to extend them just like so. So then I can see that I have really parallel lines cut by two transversals, okay? And let me go ahead and just differentiate the colors here. And we said that this segment and this segment are parallel. And my goal here is to prove that segment AB is parallel to segment CD, okay? So you're definitely going to have to use one of the converse theorems to get there. So just make sure that you mark, and then you're going to pay attention to some certain things, okay, in order for you to do the proofs. And I can see that, again, I got these parallel lines, and yeah, you got a transversal here and a transversal here. And I can see that angle 2 is congruent to 3. Okay? And by the way, I didn't mean to put 2 tick marks here. Angle 2 is definitely congruent to angle 3 in this case. So if you can figure out why they are congruent, then you have an idea on how to do this proof. Okay? Alright. Let's see number 26. Given that segment WX is parallel to segment YZ, so in fact, what I'm going to go ahead and do is I'm just going to go ahead and extend these lines anyways, right from the beginning. So I have lines and lines. We can see that WX is parallel to YZ, and 2 is congruent to 3. And this is all because of my given, okay? And my goal here is to prove that these lines are indeed parallel, okay? So when you're trying to prove that these lines are parallel, you're going to be using one of the converse theorems to do that. Okay, so your goal here again is to prove that segment WY is parallel to segment XZ. And if you can do that, you're golden. So let me go ahead and do this whole entire proof with y'all. So anytime that I'm given a given, all you have to do is you're just basically copying this and pasting it right there. So you're plagiarizing. So let's plagiarize. Let's cheat. So segment WX is parallel to segment YZ, and angle 2 is congruent to angle 3. Okay? Then over here it says definition of congruence. So this is currently in the segment, or this is currently in the language of geometry. So now I'm going to write that in the language of algebra. So I write measure angle 2 is equal to measure angle 3. And again, that's because of definition of congruence. Then, if I were to zoom in, note that I have parallel lines cut by this transversal, and since there's 2 and there's 3, right? Notice that if I were to involve 2 once again, you can see that with these lines being parallel cut by a transversal, 2 and 4 are on the same side of the transversal, okay? So that means I'm going to write angle 2 and angle 4 are supplementary. And that's because 2 and 4 are same side interior angles, okay? And now, the fact that I know that angle 2 and angle 4 are supplementary, these are in words. So now, if I were to look at the next step, this is in algebra. But I'm not going to use definition of congruence, okay? That's when it's congruent to equal. But this is saying this is supplementary in words, and now this is supplementary in algebra. So this is actually definition of supplementary angles, okay? So that means that measure angle 2 plus the measure angle 4 is equal to 180. So now I'm looking at the next step. It says measure angle 3 plus the measure angle 4 is 180. And notice that these two things are the same and these two things are the same. But what's different is these two things here. Measure angle 2 became measure angle 3. Why? Because we stated statement 2, measure angle 2 is equal to measure angle 3. So that's basically substitution. Now, let's go ahead and take a look at measure angle 3 and measure angle 4. So these are parallel lines cut by a transversal. We said that 2 and 4 are same side interior angles. And now 3 and 4 equals 180 because of substitution. Okay? So that means that now we showed that this is basically supplementary in algebra. And by definition of supplementary angles, I need to take this and convert that into words. And since this is a definition, it goes both ways. It's kind of like the previous time we used definition of supplementary angles, but backwards. So I'm going to write angle 3 and angle 4 are basically supplementary. And if angle 3 and angle 4 are supplementary, then that means that 3 is involved with this line, 4 is involved with this line, and these two angles share the same transversal and they are on the same side. So that means that with one of our converse theorems, we can tell that these lines are parallel. by the same side interior angles. Converse. Don't forget the converse. I don't know why I put a period there. Oops. Same side interior angles converse is the reason why segment WY is parallel to segment XZ. Okay, let's go ahead and take a look at number 27. Given angle ABC, so this angle is congruent to segment ADC, so this angle. So now I know that angle ABC is congruent to angle ADC. So I'm just going to mark my picture. Again, this is angle ABC. I'm going to go ahead and put a congruent mark there. And this is angle ADC. I'm going to go ahead and put a congruent mark there. So that means that these two angles are congruent. Okay? And what I'm going to go ahead and do is, let's go ahead and read this. It says measure angle A plus the measure angle ABC is equal to 180. So that means that this angle here and this angle here equals 180. And the reason being, we don't know why, but it's given. So that means that we can assume that those two angles add up to 180. And my goal here is to prove that AB is parallel to CD. Or, since these are segments, segment AB parallel to segment CD. These are not parallel yet until we prove it. So that means we're going to have to use one of the converse theorems. Okay, let's go ahead and extend these lines. So I have these two lines. They're not parallel, but they are indeed cut by two transversals. Okay, so let's go ahead and take a look at the proof. Given that angle ABC is congruent to angle ADC, we know that these two angles are congruent because of my given. But I'm not done, because I need to write that the measure angle A plus the measure angle ABC is equal to 180 because of my given. So, note that this right here is currently in the language of geometry. I want to go ahead and convert that into the language of algebra. And that means that if I'm converting from the language of geometry to the language of algebra, I'm essentially using the definition of congruence. And always refer back to your pink sheets. So now, I know that the measure angle ABC is equal to the measure angle ADC. Well, take a look at this. I can say that since I know that the measure angle ABC is equal to the measure angle ADC, that means I'm going to replace this with this, but keep these two things the same. So I write measure angle A plus measure angle ADC equals 180. And that's because we were substituting. And now we show that these two angles are supplementary in algebra form. I want to go ahead and turn that into supplementary in word form. And that's because of definition. of supplementary angles. So let's go ahead and take a look at where angle A and angle ADC are. Angle A is right there, and angle ADC is right here. Okay, so I have these two lines cut by this transversal, and my goal here is to prove that AB and CD are parallel. Okay, so here's angle A, and here's angle ADC, and angle A is part of this line, and angle D is part of this line, but note that they share the same transversal. So, again, angle A is right here. Let me use a different color. Angle A is right here, and angle ADC is right here. We can see that angle A is part of this line, and angle D is part of this line, right? And you can see the green is part of this line, and you can see the green is part of this line. But these two greens here, they share this transversal. So what does that mean? We can see that with these two lines cut by a transversal, these two angles share, or I can say that these angles are on the same side of the transversal, and they are also supplementary. So therefore, segment AB is parallel to segment CD. And that's when we use our converse theorem here. So again, this is like the previous proof. Same side, interior angles. Wonderful. 41A. I am not going to go over these two proofs, but I want to make sure that we understand that A is part of this proof, and then B is part of this proof. And you're going to be using the same image for these two column proofs, okay? And then make sure you use your given, and then prove that angle 1 is congruent to angle 3. Alright, let's go ahead and do 49, and then 50 you can do on your own. Given that A is parallel to B and C is parallel to D, prove that angle 1 and angle 4 are supplementary. So, since I am given A parallel to B, here's line A, and then here's line B. Those two things are parallel, and we can see that they already have these arrows here. C, D, these two lines are parallel, and they have those two arrows. So let's go ahead and begin the proof. A is parallel to B, C is parallel to D, and that's given. Note that we can see from our image that angle 1 and angle 2 are congruent by vertical angles. So then if I go back, angle 1 is congruent to angle 2 by vertical angles. Okay? And then we can see that angle 3 is congruent to angle 4, because if we look closely, we have these parallel lines cut by a transversal. 3 and 4 are alternate, and they're both inside the parallel lines. So angle 3 is congruent to angle 4 by alternate interior angles. And now, what I'm going to go ahead and do is look at this. So I have parallel lines. Sorry, I'm trying to think. I have these parallel lines and cut by transversal here. 2 and 3 are on the same side, and therefore they are supplementary. Because notice that well, my game plan here is to prove that 1 and 4 are supplementary, okay? And the fact that angle 3 is congruent to angle 4, right? Since I know that angle 3 is congruent to angle 4, this is basically saying that if I replace 3 with 4, then they are essentially supplementary, okay? So that's the reason why I'm writing all these things down. So I'm going to say, again, we know that angle 2 and angle 3 are supplementary by the same side interior angles theorem. And now I'm going to take the supplementary words and convert that into algebra, which is definition of supplementary angles. And now I cannot neglect the fact that I wrote these two things here, which are currently in the language of geometry. So now measure angle 1 is equal to measure angle 2, and measure angle 3 is equal to measure angle 4. And that's definition of congruence. Okay? So, what am I supposed to do? I'm trying to prove that angle 1 and angle 4 are supplementary. So now that I see that measure angle 2 plus measure angle 3 is equal to 180, once again, I'm proving that angle 1 and angle 4 are supplementary. So since measure angle 2 is equal to the measure angle 1, and that measure angle 3 is equal to the measure angle 4, we have to substitute both of them. So I will say measure angle 1 plus measure angle 4 is equal to 180. And that's by substitution. And then I say angle 1 and angle 4 are supplementary. This is supplementary in algebra. Now I want to make this supplementary in words. Definition of supplementary angles. And I'm done with the proof. And then for 50, I'm not going to go over the whole proof, but I want to make sure that you understand that here's L, and there's M, and M is parallel to N. So L is parallel to M, and M is parallel to N. Prove that angle 1 is congruent to angle 2. Okay? So I will let you do that on your own. Good luck with this homework assignment.